Let us make this example a little bit more complicated enough that it cannot be proven simply by applying one instance of modus ponens. Imagine that the robot proved to itself that this box is not liftable. And the humans in the factory who are trying to make fun of the robot said to the robot, well, the reason it's not liftable is not because it's not movable, but because your battery is not working. So now the situation is more complicated. The robot must also check its battery. So now the robot begins with slightly different knowledge in its knowledge base. So suppose that the knowledge in its knowledge base is cannot move and battery full means it's not liftable. It finds from its percepts again it cannot move. So it checks its battery and finds that the battery is full. So there are two new sentences that get written in the knowledge base. Now the knowledge base contains three sentences. As earlier in resolution theorem proving, the agent must convert all these sentences in its knowledge base into a conjunctive normal form. That means that the sentences can contain a literal or a disjunctional literals or a conjunction of disjunctional literals. So we begin by removing the implication from sentence 1 because an implication cannot occur in a conjunctive normal form. So when we remove implication from the first sentence, we get this sentence. But the sentence is not yet satisfactory. It is not yet a conjunctive normal form because this is a disjunction of conjunctions, and what we want are conjunctions of disjunctions. So we apply the De Morgan's law, and now we get the following sentence. We're simply taking the negation inside, which flips the conjunction into a disjunction, and now we have three literals connected with disjunctions, and this is a conjunctive normal form, disjunctional literals. So now we have in the knowledge base three sentences, all three of them in the conjunctive normal form, either literals or disjunctional literals. Recall that the robot wanted to prove not liftable. So it takes the negation of that. This is again proof by refutation. So it considers liftable. So now the knowledge base has four sentences. This fourth sentence is coming from the negation of what it wants to prove. Once again, the reasoning begins by the literal that it wants to prove, in this case liftable, and it finds a sentence in which the negation of the literal is true. So once again, we begin with the sentence S4 because that is what we want to prove. And we find a sentence in the knowledge base which contains a literal, which is a negation of the literal in the sentence S4 that we want to prove. We resolve on this because they both cannot be true, and resolution here simply means that we drop them. Now, in this sentence S1 that is under consideration currently, we have two literals. We can begin with either one of them. Let us begin with not battery full. We'll try to find a sentence which contains a negation of this particular literal. There is a sentence S3 which is a negation of this, so we'll resolve on this. Battery full and not battery full because they both cannot be true. We'll drop them. Now in sentence S1 we are left with just one literal, can move. We can try to find a sentence in the knowledge base which contains a negation of that literal. Here it is. And so we can resolve on them, and we resolve on them, we drop them, and once we drop them, then we have a null condition, which stands for a contradiction. So we reached a contradiction. Therefore, the assumption that this was liftable cannot be true. Therefore, not liftable is true. And we have just shown that resolution theorem proving, in this case, proves what the robot wanted to prove. One important point to note here is that of focus of attention. Because of the conjunctive normal form, one important point to note here is the issue of focus of attention. Often when the problem space is very complex, for example, when the number of sentences is very large, the sentences are very complex, it can become really hard for the logical agent to decide what to focus on. But because we have converted everything in a conjunctive normal form, and because resolution theorem proving is making use of resolution, therefore, at any particular time, the logical agent knows exactly what to focus on. You always begin with this literal. You always try to find a sentence which contains its negation. You always resolve on that. You take a remaining literal in the sentence and proceed forward. This focus of attention, this computational efficiency of resolution theorem proving, is arising because of what are called Horn clauses. A Horn clauses is a disjunction that contains at most one positive literal. This is happening in S1. This is a disjunction that contains at most one positive literal. This is a negative literal. This is a negative literal. And the fact that it contains just one positive literal is a very powerful idea because that's where the focus of attention comes from.